Welcome everyone, I'm Andrea, I'm Senior Engineering Manager here at DFINITY, and I'll be your host for today's Global R&D. So as usual, we have a pretty exciting agenda. So we have a couple of pretty extensive updates, both on the roadmap and on Caffeine. Then for the feature part, we'll hear about an update on CNS, which is on-chain name service alternative to DNS. And for the demos, we have a couple of internal demos, one on the component model from Motoko, proof of concept of this, and about the immutable blob storage for Caffeine. And for the community demo today, we have Diode, which is one of the first projects integrated their production system with VetKeys. So without further ado, let's dive into it. And the first one is Sam with the roadmap update. Please, Sam.
Thanks, Andrea. Let's please go to the next slide. My name is Sam. I lead the engineering team here at DFINITY. So welcome, ISP community. Hello to our entire team. So every few months, we do a bit of an update on where we stand with respect to our roadmap milestones. The last such update was just before the summer break. That was in June. And so even though there was summer break, July, now August, 2 months later, we have already more milestones we can report on. So it's exciting to give a bit of an overview of that. In the compute platform space, there is one activity where we work on quite a bit. That's this Blob storage. I will not talk too much about it because we have an extensive update today by Yvonne-Anne and Dave later on in this Global R&D. You may remember some updates we shared about out calls where you can configure more, have more configuration options to not rely on full consensus. That's maybe another important update we have been working on in the compute platform space. In the decentralized AI space, or just AI in general, we had in June the event in Zurich about Caffeine. Then in July, there was a big event in San Francisco. We also reported on that. So that concluded this alpha phase. And today, Kepler will give us a bigger update on what's ahead. So that's why you find this little coffee mark. But I'll be reporting in a bit about Ignition, which was the milestones about having LLM access in smart contracts. So that's something I'll talk about. There was not new big milestones in Chain Fusion. We are working towards the Dogecoin integration in privacy. We work as well on more protocol changes after we have launched VetKeys. So there's not so much new to report there. But in platform decentralization, we'll achieve the Levitron milestone. I'll be talking about this. In the identity space, we launched a new version 2 of Internet Identity with a completely overhauled UX. There's still more changes coming. It's being integrated in Caffeine and other new apps. So that's a space that is very active these days. Digital access assets. We do some work for real-world assets. That's the main focus there right now. And then in the governance and tokenomics space, we achieved the Neon milestone, which I will also be talking about. Developer experience, lots going on, but not covered today. So that gives you a bit of the overview of all the different sort of swim lanes or areas we have in our roadmap. And so that's why now let's jump in and look at decentralized AI. Here we declared this Ignition milestone as complete. Already back in February, we had a presentation by Islam where he showed how you can access LLMs that are actually running off-chain, but you can access them quite conveniently from a smart contract. In the meantime, there's been more library extension. You find Motoko libraries, Rust libraries, TypeScript libraries to make use of this LLM AI worker. And that complements basically the ability to run AI models on-chain. But if they're too big or you really want one of the frontier models to be used, then you can use this approach. And we have received interest from the community and improved based upon that. And we concluded now this work with the Ignition milestone. Overall, our focus in the AI space is very much on Caffeine going forward. So we'll not spend too much more time on running on-chain AI for now, for the moment. So that's what we did in the AI space. Let's please go on to the next one. You may remember early this year, we achieved the solenoid milestone, which was all about decentralizing the boundary nodes. Boundary nodes are the infrastructure that provides access to the internet computer, and that gives users the ability to choose how they connect to the internet computer. And so that allows them to be independent of, for example, the DFINITY Foundation. They can pick their preferred sort of gateway. And based upon that, the next step now was to make access logs and metrics that give more information about canister methods being called, or client identifiers, request types, all of this type of interesting information that allows you to see what's going on the IC, available to the public. And Rudy gave a comprehensive summary about that in July when this milestone was achieved, and I included a picture of the forum post which shows you the architecture and the Medium post that explains what was done. So everybody who would like to know more how the IC is used and learn what patterns we can extract from that, I recommend taking a look at that. So that's what we did in terms of platform decentralization. And then please to the next slide. In the governance and tokenomics space, we were working on various, sometimes even quite small improvements, but they all can be sort of summarized under activating the community, making it easier to participate, understanding how you stake so that you can participate in governance, but also that you know how much yield you would get for the neurons you have staked. And so that all this work was summarized under the Neon milestone. And for example, we had a presentation in August by Youssef explaining updates to the NNS front-end app, which now indicates much more how much yield you would get or guides you better through the staking process, various UX-related improvements. And more on the back end, we had two presentations by Al-Shabir on SNS liquidity pools, so that allows basically SNSs to put some of their treasury into pools, into liquidity pools, so that the community can more easily trade tokens. So there is more liquidity, more fluidity for tokens, and hopefully engages again the community. These are two examples, but there was much more we did under the Neon milestone, and that's another milestone we achieved in the last few hours. Actually, it's not completely achieved, but we are just about to achieve it in the next few days. So that's the third update I wanted to share. And with this, we already go back to the next slide, please, where we see again our roadmap. Again, today, you hear more about Blob storage, you will hear more about Caffeine, and I'm sure you will hear also more about developer experience in the weeks to come, because there's a lot going on in that area. So with this, I hope that gives you an update, and see that even though there was summer break, we were quite busy. Back to you, Andrea.
Thanks, Sam. It's really nice to see that all many things are happening on various fronts. And the next one is already the one that most people are waiting for. And so, Kepler, please tell us about what's happening on Caffeine.
All right. Hello, everyone. My name is Kepler. I'm the engineering lead for Caffeine, and I'm excited to tell you more about Caffeine. You probably have heard already a lot about it. And today, actually, before we jump in and talk about what will come next, I actually wanted to touch base a little bit of why Caffeine and why now. If we go to the next slide. So Bill Gates in the mid-90s, he said, if your business is not on the internet, then your business will be out of business. However, this still applies to these days. If you have an idea, if it doesn't fit, let's say, a very specific scenario, then actually building a little bit more complex idea still required users to go find a team, maybe find a company that will do that for them. They need to hire a designer, they need to hire a developer. And then after they have the application created, they still need to make it operationally ready, deploy it somewhere, make it run, and make sure it keeps running. If you go to the next slide, this, you can imagine, is very hard still. So for an end user, or for somebody that's not technically savvy, not an entrepreneur that actually will be able to do things end to end, they actually, if they don't have a lot of funds, they won't be able to actually do that. So imagine that a user would come, have an idea, and they could actually just say with natural language that here's my idea. Maybe I want to build a portal. I want to build a gallery for my family. I want to build an e-commerce app where the checkout flow would look this and this way. And I wanted to make it live on the internet and operationally safe, potentially even in the same day. Well, that is what Caffeine brings to users. And it's possible now because AI had some advancements in the last few years, and we can make it operationally safe through the technology that ICP provides to users. And it will also be very soon available for anyone with a smartphone. So that's the team that the person would hire, that instead of hiring the team, actually they just talk to AI and then deploy it to ICP. So if you go to the next slide, you can then also see the journey we have done so far. So on June 3rd, we had the World Computer Summit, where in just a few months, we were iterating through different versions of Caffeine. We then did a demo where things were still in closed version, only very certain people would have access to it, and we opened up for invitation code. So this means that users would be able to then go and add their email, and then they'll receive an email to get the invitation code to then access and try the platform. Then in San Francisco, in July 15th, we actually launched the alpha. So that's when the first users got access to Caffeine and could try out and receive the invitation codes. In that same day, we actually did some hackathon as well, where we distributed some prizes. Users built in a few hours applications where they then demoed very interesting ideas. And it's interesting to see in between July and now how much things have evolved. We now see, for example, some users have actually generated version of the same application that they created, upwards of 358 versions, where it gives you an idea of how far they can go by talking to AI and adding extra features and making things more complex. We are now also in the middle of general availability rollout. What this means is that we are going to open access more broadly, and soon we'll also be making available the app market for Caffeine. If you go to the next slide, we have divided the rollout in different phases. So phase 1 is the public master chat. So that happened in August 19 now, where we opened the Caffeine master chat to everybody. Well, I think it's still important to remind everybody that Caffeine is not the ChatGPT-like application where we'll just go and chat with it, but it also provides that functionality. But the actual main feature that you will get with Caffeine is of creating applications that you provide your build instructions or your ideas, and it generates those applications and then deploys that. To do that, users still require the invitation code, and they will get it more now also during this month. But it is already available for anybody that lands in caffeine.ai to then talk to Caffeine, talk about self-writing internet, talk about the internet computer, and get some insights. And for those that do that, they can also add their email to then get an invitation code still. If you go to the next slide, in September, we will open phase 2 and which starts soon, next week. So we open phase 2 of the general availability, which means we will onboard the full wait list of Caffeine. For those interested, they can look in Caffeine AI on X, and we'll also post more updates there. But what this means is, so far, organically, we already had 15,000 people waiting in the wait list. And for those, we only invited around 3,000 at the moment. And these users can go in once they get the invite code to build applications as what you see here in the picture. For example, I made this for fun, just creating an application where I can upload some photos for my vacation that I came back now from Portugal. And once this is available, then all of these 15,000 users will then be able to go in Caffeine and explore still without any payment attached to it. They will be able to explore all the functionalities of Caffeine. Then we go into the third phase of the release. So if you go to the next slide, which is the public availability, so really the general availability of Caffeine. And this happens in October, where we can really welcome the self-writing internet, and users will not need any invitation code, so everybody will be able to go into Caffeine. Everybody will have some free credits to try the platform, and people will be able to then create some projects. They'll be able to iterate on some of their ideas. But for those that really want to scale their ideas, then they will be able to then subscribe or have a pay-as-you-go plan, where they'll be able to then buy some credits and use the platform with its full functionality and all the ability it has. Then on phase 4 is when we really unlock most of the functionality of Caffeine, where we add the creator's economy. So Caffeine at the moment has this app market. We don't yet have a date to release this. This is exactly a phase that comes after we go general availability. But the app market will enable any creator, any builder in Caffeine to, after they have their application, that they find it in a stable way that they consider live, and that they consider they can, for example, resell it. They will then be able to publish it to the app market. They will be able to do it for free. They just make it available for other people to use, or they can resell it. And if they do that, then you can imagine the possibilities of now anybody with an idea can turn this idea to life and then potentially make some revenue out of what they publish. And then what does this mean for ICP? So if you go to the next slide, so Caffeine will expose the internet computer to many more users. You can imagine now that all of these end users that are using Caffeine, maybe for those that are not even aware of ICP, they'll become aware through Caffeine and understand about where things are live, how it's operationally safe, and Caffeine can help educate users about the importance of data sovereignty and on how important it is on how to manage data, for example. Then it will also bring much more canister installations and much more cycle consumption to ICP. Yeah, so Caffeine will also bring a new wave of builders that will join the community. So now people, instead of actually needing to be developers, they just need to have ideas, and they can talk to AI and generate and deploy those. And one other thing we are bringing also, so Caffeine, we need new features, such as being able to upload potentially terabytes of data. And at the moment, this was all happening directly to ICP, but now we've been developing Blob storage solution also for that. And Yvonne-Anne will talk to you, Yvonne-Anne and Dave, more about this. And this is something, for example, that Caffeine brings also to the entire ICP community soon. So yeah, everybody that wants to try Caffeine, they can already dock with the master chat. Just go to caffeine.ai and just keep an eye on X, on Caffeine AI, to see more news. Thanks.
Thanks a lot for the update, Kepler, and really looking forward for the next phases. And so this concludes the update part of the agenda, and we can now move to features. We only have one feature today, which is about chain system, CNS, and really an update from Bartosz on this.
Hello, everybody. My name is Bartosz. I'm a software engineer at DFINITY, and I want to share the screen because also the next presentation after this one is a demo for which I will need screen anyway, so that's why starting already now. Right, so Andrea already mentioned what is a CNS. It's a chain name system, which is like a DNS alternative hosted on the IC. It has similar structure, but the fact that it's being or will be controlled by the DNS will allow new functionalities. If you want to know more background, please go to the GitHub repo pointed to here. And also, what is the minimal CNS? It's a subset of the CNS, because CNS in itself is quite complex long-term project, and it requires lots of resources to implement. And so we wanted to see whether, is community interested in such a system? Is it the right type of system that we should work on? So we trimmed down the design and implemented and launched now. And we want to gather metrics and feedback from the community and see which direction should we go. To just briefly, I will not describe the entire structure of the CNS or the minimal CNS, but just to mention that the minimal deployments consists of the root of the system plus a TLD operator for a single top-level domain .icp, which is also a naming mechanism for the domain. And we provide also CNS resolvers, which are for the developers to access the CNS, JavaScript, and Rust libraries. So now it's open for testing. It's populated with domains for well-known canisters and names for the IC subnets. It supports also reverse lookups for well-known canisters and subnets, and anybody can also use it to register test domains for like .test.icp. It's without any ownership checks because that's the complex part, but also no stability. So if it gets abused, we might remove some of the test domains that get registered. Again, please go to the URL to get details about this. This is a team effort, not only from DFINITY, but also from the community. So I'd like to express also special thanks to Byron Becker from Cyclops, who provided both ideas and code to the system. So this concludes the part on the CNS, and I'll steal Andreas' role and move on to demos directly. And for the demos, I'll tell you about Wasm component model for Motoko with Motoko. So what is Wasm or WebAssembly? Component model is an architecture for building libraries in Wasm and or applications that can cooperate to fulfill its tasks. And the components in the Wasm component model are specified with a special language, which is kind of like language called WIT, and specifies what functionality is being imported or exported by the component. And one can combine various components into a bigger application using something called WEG specification. I'm mentioning it because it's going to be important in the what follows. Now, if you are a frequent guest to the Global R&Ds, about 2 months ago, you've seen this slide where Andri actually described the component model in more broader scope and how it fits the IC. But he also showed how we can compose software written in different languages to run on the IC. Well, this is the plan. Actually, it is already a pretty complex task. And actually, I mentioned WIT, the interface, so I'm adding here also this parts here. Now, and we're going to talk about this. Yeah, so how do we actually enable in Motoko access to the components? Well, and why do we want to actually enable it? Well, some of the reasons Andrew mentioned 2 months ago, but let me maybe repeat. So Motoko needs really more libraries. It's a new language, so it doesn't have the kind of long history and lots of libraries that could be used to write your project. On the other hand, lots of libraries exist in other languages, in some older languages, which provide the functionality, but Motoko cannot access them. So we'd like to change that and make it available to Motoko developers as well. So please review the Global R&D from 2 months ago if you want to know more about the motivation. So how do we go about this? Well, we modify the Motoko compiler to enable this cooperation and provide tooling. And to make this happen for the IC, we would have to also complete what was announced 2 months ago. Now, so how do we want to make it? I mean, we've seen on the image that it's like there are many parts of the system and then weak, whack, and other things that you would have to use to make it work. Well, that might be overwhelming, especially if you are also new to Motoko. So what we really want is to make it easy so that if you want to use any component model, any component functionality, you proceed as you are working so far with Motoko packages. So you can import something from somewhere and then use it as usual. And with all the type checking as you are used to, and also you don't have to learn about components with WAC and other things. The only thing that we cannot avoid is that, well, the resulting binary will be a component. It's a different format than what we are producing right now. Right now we are producing Wasm modules, not components. So that's why we decided that we would like to maybe show it to the developer. You are actually using components, but that's the only thing. I mean, we could use here the, say, NO or some other prefix we decide for components so that people are aware that the binary that it produces is different. So now going back to the image that you've seen, well, it is complex, but we try to take this complexity away. So we want to encapsulate everything that's happening here. As everything will happen automatically. You will not have to generate any WIT or WAC files. And also, when you import the functionality, you will import it through a Motoko API. So this is what our current prototype achieves. So no Wasm tool experts needed. It has a limited scope. It has only it works for simple functions without a state and supports basic types. And it's only for Wasm 32. That's current restriction of components themselves, right? So they do not support Wasm 64 yet, but this is also a work in progress. Another thing that we have to do still manually is Motoko bindings. So this is this part from WIT file, but this is very simple, and we will provide also, like as next steps, we will provide them with bindgen in an automated way. And of course, so we want to make the code available behind the flag so that you can also experiment with this. And when the feature is ready for components, we also want to support Wasm 64. Now, this is a multi-team effort, but again, I'd like to express special thanks to Andrew, Christoph, Claudia, Camille, and Ryan. And now let's move to the demo. I hope now you can see some code here. So in the demo, we have two components. One is just some dummy one meet and greet, which exports functionalities for greeting. Say hello, say bye, and well, we have the bike has a formal and an informal version. It's just to use arguments of different types. It has also some other functionalities here, but these are just for testing, so I will not talk about it. So let's take a look at how the WIT file looks for that, just so that you get a list of how things look like in this world. So, but these are the important functions that we have, and this is how they are being wrapped into Wasm, into Motoko. The other component we have is more useful, hopefully. So it's using existing Rust libraries for verifying BLS or Kinesis signatures. And it kind of provides some, either direct the same interface that these functions, or here we have just also, again, to test, wraps them into some structure and then tries to do some type checking and so on, right? And again, so we have the WIT file with these three functions and the wrapping into the Motoko. Now, how do we use this? In the program, as I said, we want to have really imports in the same way as we do it right now in Motoko. So there are different variants. You can also do the renaming, or you can just import directly from a file. And then, for example, then like for the meet and greet, you have these two functionalities, say hello and say bye, right, with different arguments. So this is what we can call. Now for BLS signatures, here we use the renamed import, right? And so we are calling it here and also checking the results, and also do some test reporting for this version where we have the this comes here. So if you want to do this with packaged arguments, so we are passing here maybe some dummy arguments which are not properly packaged. Here are packaged, but still the values are dummy, so that should fail as well, right? Okay, so how do we work with this? So let me compile this. So what happens now is, so what the compiler does, it analyzes the program and it creates all this WIT and the WAC file on the fly. It tries them into temporary files and then later embeds, creates a Motoko component and composes the component, and the final binary that you can run is written to a file. And then now you can run it as a time. So we cannot run it on the IC yet, but went on Wasm time. And you can see all the things that were happening, so that indeed kind of the functionality that we are testing works as expected, and also the error reporting works. And I think I'm almost on time, but let me maybe mention one more thing. I said about the tests. What's over here? I said that we have this type checking. So if I say I change it here and want to give a different like wrong type of the argument, then of course the compiler will complain. So now I can change it back, and then the compiler will work again. Okay, that's everything I wanted to show you. Thank you very much for your attention, and stopping sharing and giving back to you, Andrea. Thank you.
Thanks a lot, Bartosz, for both presentation. We can now move to the next update and demo, which is about Caffeine Blob storage that both Kepler and Sana mentioned earlier in the talk. And Yvonne-Anne, please take it.
Thanks, Andrea. My name is Yvonne-Anne. I'm Director of Research here at DFINITY. And I hope there's now enough hype with that Sam and Kepler built up. So now, what is this Caffeine Blob storage? But before we go there, why do we have it? If you wonder what the most popular apps on the internet are, here's the list. And what do they all have in common? They all store tons of data. Photos, videos, etc. And now that Caffeine makes it easy to build such applications, we need a way to deal with this data on the internet computer. Imagine a sovereign file sharing app. If you have like 1 terabyte of user files and you want to store that in custom memory, that's like $5,000 a year. Not exactly cheap. And if we go to the next slide, we have we can benefit from the nice property that actually for many applications, the majority of data is written once and then read many times. And for this type of data, the ability to change individual bytes is unnecessary. What is crucial, though, is that integrity is preserved and that the cost and speed are fit well with the requirements of the app. And that's why we have been working on a dedicated storage service for apps generated by Caffeine. We launched it last Friday, and it has been used to create quite a few apps successfully since. For this service, we had to write code for the front ends and back ends that Caffeine generates and teach Caffeine's AI how to use it. And we also built 2 new components. On the one hand, the cashier canister, which is responsible for billing in cycles, and a new off-chain service called a storage agent that is used to upload data to a storage system if authorization is there and notify the cashier canister of the resources that have been used to bill for them appropriately and also for download. Let's look at this in a bit more detail on the next slide. The core business logic of your application and the front-end code, generated both by Caffeine, they still reside within canisters, as always. And now let's look at what happens when a user interacts with the front-end, for example, on their phone, and wants to upload a large file. Then, on the next slide, you see that the application will actually not store the file itself in the canister. Instead, the front-end computes a cryptographic hash of the file's data and stores that on-chain. And this then acts as a secure, verifiable reference, which can be used to detect tampering. And when a file is no longer needed, this hash can be dropped from the backend canister. The actual heavy data files, images, videos, documents, are then sent to the storage agent. And on the next slide, you see that before accepting an upload, the storage agent checks for authorization by the backend canister, integrity, and whether the backend canister has high enough balance. at the cashier. And if all this works out, then it actually stores the data on a dedicated storage system. And on the next slide, you see how the download works. It's very, very similar to the flow I've just described. And after front-end downloaded a file from the storage agent, it can check if the hash matches and verify that the data still is the same. On the next slide, we will see how paying for the storage service is done in cycles. And this works as follows. Periodically, the agent asks the backend canister for the hashes of the data that is no longer needed, and then removes the corresponding data from the storage system. This relies on tracking weak references being garbage collected. And this is a very nice piece of work that was recently added to Motoko. Then after the deletion part has been done, it sends a summary of the resource usage, the amount of data stored, the number of upload and download requests, etc., to the cashier canister. And then the cashier adjusts the backend canister's balance accordingly. If the canister's balance at the cashier reaches 0, the storage agent ceases to serve new upload and download requests, but it will retain the data for a few weeks. When the cashier observes that the backend canister balance is low, it will notify the backend canister to make it send a refill of cycles, and then the service is automatically reinstated. In summary, Caffeine builds canisters that use this storage service out of the box. It creates the backend canisters that automatically provide the necessary endpoints and to front ends to register data, and to the agent for the deletion and notification for the cashier. And also the front ends that are being built by Caffeine, they are equipped with the libraries that handle data registration, upload, download, etc. And on the next slide, there's the good news that Kepler alluded to earlier already, that this is actually just the first step. Right now, we have a very basic version of this service running, and we are working hard to make it more robust to support the general availability of Caffeine. And then at the later stage, we will decentralize this service with more agents and a very cool new erasure coding protocol that beats existing solutions and allows us to have very low replication factor for the data we store. And last but not least, we will integrate this service into the Internet Computer Protocol so all canisters can benefit from it. And now I hope you want to see this in action. Dave will take over, and while he gets ready, I would like to take the opportunity and to thank everyone involved. This was really a cross-team effort. Thanks for everyone who helped us make this a reality.
All right, so thank you for the technical details, Yvonne-Anne. I'm going to take you on a quick tour on how this looks with Caffeine in production. We're not going to go through the prompting step because that's already been done. That would be outside of the scope of this demo, but I'm just going to show you, I'm going to take you through the app that I created to showcase this feature. So I created this like online learning course platform where obviously the goal is you can share videos, you can share PDFs, large files with everyone who wants to learn, wants to enjoy those courses. And you can already see here like the media integrated, embedded. But first, what I want to show or want to start with, I want to create a course. So I'm going to have like an amazing course. I'm going to select a couple of videos and PDFs that I want to add to this course. And then I can upload those files. And what we can see here is basically we have the front end upload those 4 files in parallel to the Blob storage, to the immutable Blob storage. And you can see here we have like a small PDF, 1.3 megabytes. We have a 5 megabyte PDF. We have a 100 megabyte file and a 37 megabyte video. So those 2 are videos. And yeah, while they're uploading, I can tell you that we already identified a couple of key points that we how we can make this faster, and we will make this faster. As you heard, we're just getting started on all this blob storage and maturity, but you can see that we can already work seamlessly with any kind of data, not just PDF or MP4s. That's just what I've chosen to showcase here. But all of those files have been successfully uploaded. We can add some description, which I'm not going to do here. But then we can create the course, and we see it's done here. We can set it to public. And now you should be able to see the course that we just uploaded, our amazing course here.
In this video, we take a look at the...
Let's not play this right away, but you can see here we can watch the video, we can skim through it, we can look at the PDF, and we can also jump to the other chapter. And again, just look at all the files we've just uploaded. Obviously, these are kind of small files. You could also already upload to your canister storage, but then we can also look at larger videos. For example, this is a 2.5 hour video, and again, here we can just seamlessly scroll through the timeline and look at it. And last but not least, I want to show you probably a well-known video in the public domain, which is Big Buck Bunny. And you can see in this case that we can stream this. I think it's a 4K video, without any problem from the Blob storage to your Caffeine generated app, whatever it might be something like an online learning course platform or a YouTube clone or whatever, your own favorite videos from your vacation. And last but not least, I can also show you that this is not just an embedded YouTube video. If you look here into the resources tab, we can see that when I jump to a new time point, we can see that it downloads those blobs in real time. And if you look at the actual request URL, we can see that we're accessing the blob caffeine.ai URL, which is serving those blobs. I think that's all I have from the demo here. Back to you.
Thanks also, David and Yvonne-Anne. That was really great to see in action. And we are already at the last demo of the day, and we had Dominic from Diode, who's going to tell us a bit more about Diode and also about how they integrated with VetKeys. Do you want to share the screen, Dominic?
Yeah, I can just share my screen here, and then we can go through that. So let's start with Diode. So I'm actually super excited about what I just saw here from Yvonne and also Bartosz, because I think we're going to need both of that as we go ahead here. So to give some context, Diode is you can imagine the Microsoft Teams Slack replacement that is living on chain and is using the chain to provide self-custody for our customers. And the reason why Diode exists is really because of this growing tension that we see in the international legal system between people owning the data, the people producing the data. You might be a European citizen, and then the company actually operating Slack as a US company under different laws. And this US laws, EU laws, but also Brazil, for example, also Russia, also China, they have all this problem that if you bring these two different entities into the mix, you create problems like who actually owns the data, what is the governing law on this data. And so far, before Diode, the answer was always to you could self-host and run your own servers and do all of that, or you go all cloud and you try to deal with the trouble. Some of these legal troubles are still ongoing. Microsoft is still fighting in Ireland. There's a big GDPR clause, and we don't know what's going to happen with the Cloud Act. So what we want to do is we want to say, let's try to shift this problem technically, right? There's for sure regulation making progress, but we can also solve it technically. And the prime example of something that solves an issue like this has been email. You don't see the same problem that you see with Slack and WhatsApp and all of these tools with email, because email is a pure protocol. And email is amazing because you can choose out of 100 different email clients, and these email clients do not own your data, right? The data and the email protocol is independent of that. And so this is where we came in and saw actually with blockchain now you can provide and create all these experiences that before blockchain were not possible, because you have state on the chain. You can create actually a Slack clone. You can create actually a Google Drive clone. You can actually create all of these tools while keeping full self-custody. You own the data, you have control of the data. It's just a protocol. So I have a screenshot here of the Diode app. I want to try to be conscious of the time. So let's get into this a little bit. So it's not, we don't focus on like messaging consumer to consumer, like WhatsApp and Signal. This is really focused on, you have a company, you have an organization, you create an organization and you tell your employees, your members, that you want to use this tool to collaborate, exchange your chat messages, exchange your files, and so on. And that has been from the ground up being a peer-to-peer protocol. So that means here these yellow boxes are Diode clients being online at the same time. And so if I send a chat message, if I send a file, those are being sent from one client to the next client as they're being online. And this works great as long as everyone is online and these things just start happening. But what we see more and more is that actually as people become more mobile first users, often what they do is they open the app, they send a file, they assume the file is being sent, and then they close the app, right? So what's happening is here we have Frankie and Loki. Frankie is coming online, trying to send the file, but actually nobody from the peer group is online. So this peer-to-peer network doesn't work if nobody's online. And this is where we started to bring in canisters. So we have this, we call it the zone availability canister, because when you create a group, we call this in Diode lingo a zone. And so you create this canister that is always online. Even if nobody else is online from your peer-to-peer group, the canister can be that bridge to store data, to store messages, to be the one to ensure that once Loki comes online later, when Frankie is offline, the data is traveling between those. So again, by default, the Diode app is like a local first self-custody app, but you can use like a canister to ensure like this mobile experience, or like when people are offline experience is working really, really well. And that's what we have started doing here. I want to talk a bit about what we did here most recently. And that just comes in back to what Yvonne said. Like we did what everyone else did. We built like a file system API inside a canister. So we are able to upload actually all of the files that people share. We started with messages, and we added metadata, and now finally we have also added all the files that you can drag into your zone. And so there's some change tracking. So you can if you keep your local system in total sync, you always only want to get like the most recent files, because everything else you already have. So there's a change tracking system. But also if you have no files, like on mobile, usually people don't sync all the files from a zone. You only want to be able to browse. So there's a directory index, and you can just browse by directories as well. And all of that we keep in this new Motoko feature. So we're big Motoko users. And Bartosz, I'm waiting for that Wasm module to be able to use all of the cool Rust modules that I've seen. There's unfortunately not so many Motoko packages always. So we're using the new enhanced optical persistence for most of the directory tree, all the metadata, and everything that points and describes the files. But then the blob storage itself, like the bigger files, are in a stable region, right? That can grow, but as we just heard, they're also limited. They're also pretty expensive, and so we keep them in the stable region in a ring buffer. So as a zone owner, you can decide, I want to allocate like a gigabyte of data, maybe 5 gigabytes of data. And this is how much I want to expense for this kind of caching in the availability canister. So everyone else can get the files. But when it rolls over, basically some files are getting deleted. I'm really looking forward to play with the new blob storage in the Caffeine system. So I hope that is going to be available to us very soon. I want to jump in a bit deeper because I'm running out of time here into encryption and VetKeys. So everything we store in the canister is being encrypted with a scheme that is called the bit message scheme. It's pretty old. It was when blockchain came up and Bitcoin came up. It's like a system established for really messaging in a state where it's like non-interactive. So you put the message somewhere and someone else picks up the message later on. It's a pretty simple system. It's using asymmetric keys, which for us is really nice here because it means you only need a pub key, a public key that you can make available to anyone to read. And then using that public key, you can encrypt a ton of files and just keep uploading. There's nothing you need to do to basically upload and send files. But if you want to be able to download and read the files, you need the private key. And you need to get access to that private key. put some links here into the the bit message documentation here, but also our implementation of that in Elixir. And so this kind of brings the same problem with it. Now we have this private key that you need to read the data, but again, like what if Loki is offline now? So Frankie wants to send the file. We solve the problem with the file, what's in the blob storage. But what do we do with the private key? How can we send the private key without exposing it to like everyone in the world, or to everyone who can read the canisters, to the node operators in the worst case? How can we protect that? And so there's this technology called the VetKeys, and this is something that we started using and are using in production right now to protect these keys. I'm gonna jump a little bit into how my understanding is as we implemented this, how the VetKey is actually protecting it. But to make it really short here, we take the public key, we generate basically the key pair off-chain, private key, public key, so that allows the peer-to-peer system to exchange it if people are online actually. But if people are not online, it uploads a protected version of the key into the canister, and that protected version of the key is protected using this derivation function of the VetKeys. And when we want to restore that, in the same way, Loki here, he can get the protected part, derive using the VetKey mechanism the missing piece of it, and restore the private key. Now, this is like the pseudo curve math that you can imagine here. So what's happening is when Loki is wanting to restore the key, he's first sending like a transport key. So he again generates a new temporal key, a public key, and then sends that request to the first to the node system of the canisters, and they basically multiply or add, depending on the terminology, to this transport key their shard, their fractional knowledge about the secret here, from one to the next to the next to the next. And so that means they add this to the transport pub key. Each node itself doesn't know the full private answer, and even the result out of all of these additions is still encrypted in a way that none of the nodes can read it. They don't know what actually is behind the secret. And then when they send it downstream back to Loki and he got it, he can then use the private part of this transport key that he just generated before that to decrypt it and get the real key part that he then uses to restore the bit message private key, which he can then use to read and restore the data. We do a very simple validation that's kind of built in the bit message system because it's a public private key part, and the public key is public. We actually make it public knowledge. Once he gets the private key from the canisters restored, he can check that this private key does in fact return the correct public key. So that's diving into VetKeys here. I'm not going to explain you guys what a canister is. There's more if you want to know about this on our website, on Telegram. You can reach us on. Of course, we also have a Diode group, but I also want to really quickly show the app. So this is the app in action. We have a couple of team members here. We have some storage. I can see in the zone identification, there's a canister connected to that. That's actually a production canister. Shows the version number, some of the total storage information from stable memory. And what I can do now is, these are all self-custody friends. I can create a new folder. And I can choose a file. Yeah, let's do this. So we're programming everything we do in Elixir is like a pretty French programming language, but so we also created an ICP agent in Elixir. So this is being uploaded now to the canister. You can see there's a progress bar. This is green because actually nobody else is online here. So Rosie, Herbert, or Loki, they're being gray indicators. They're not online. And because they're not online, it cannot be synced, but it can still be uploaded to the canister. I mean, this is very similar to the demo we just earlier saw, but this is actually in the canister storage. As soon as we get our hands on large blob storage, we'll store it there. So we want to create Frankie. I'm going to, from the command line, run Loki's account here. And so this is the case we had in the picture where now people are uploading, downloading asynchronously while the other one is offline. So the peer-to-peer system cannot do it alone. And so Loki, when he comes online, he doesn't see the directory. He's not aware of this. But in the background, the canister is being checked, and eventually the directory pops up. The file is seen. It's from the directory index seen that this file exists, but it's not yet synced. So we can request it to be synced locally because locally Loki wants to work with the picture, and we can see there is a August summer event in Berlin for Elixir engineers. And that's it really end to end. So this is the way we bring this down to Loki. It's encrypted using VetKeys, and there's a key recovery using the newest canister features. If you want to see the code, I linked that in the presentation. It's all open source how the canister is using it. And I'm happy to be there for any questions. Thank you so much.
Thanks a lot, Dominic. This is really exciting to see all these things actually coming together and see DAC used as the infrastructure for your service. We are at the end of this month Global R&D, and thanks a lot for everybody who attended, and see you next time.